New Syllabus Mathematics Book 2, Exercise 2E. Question number 5 from this exercise. Using the elimination method, solve each of the following pairs of simultaneous equations. Now, first part from this question, two linear equations are given in different variables. First equation, x plus y equals 0.5, and the second equation is x minus y equals 1. We know that the elimination method is usually used when the absolute values of the coefficients of one variable in both the equations are the same. For example, the absolute values of the coefficients of x in these two equations is 1, and same as the absolute values of the coefficients of y in these two equations is 1. So first of all, let's name this equation 1, which is x plus y equals 0.5, as equation 1, and I'm going to take this second equation, which is x minus 1 equals 1, as equation 2. Since we are solving these two equations by elimination method, so I'm going to add these two equations to eliminate variable y from these two equations. So adding equation 1 and equation 2. So first I will write left hand side of equation 1, which is x plus y, plus left hand side of equation 2, x minus y, equals right side of equation 1, 0.5, plus right side of equation 2, plus 1. Now I'm adding these two equations horizontally, so let's simplify. So we get x plus y, positive x, positive multiplied by negative, we get negative y. And if we take the sum of 0.5 and 1, so their sum is 1.5. And now positive y, negative y becomes 0. And x plus x, they are like terms, so their sum is 2x, equals right side 1.5. To find x, let's divide this equation, both sides of this equation, by 2, or simply you can take this 2 from left to the right side. So this equation becomes x equals 1.5 upon 2. Now simplification, we can also write the fractional form of this decimal 1.5, which is 15 upon 10 multiplied by this number 2 is basically 2 upon 1. So if we take the reciprocal of this 2 upon 1, so this reciprocal becomes 1 upon 2. And now 15 and 10, they have common factor 5. So 5 times 3, 15, and 5 times 2, 10. And now 3 multiplied by 1, 3, and 2 times 2, 4. So we get x equals 3 upon 4. And if we divide 3 by 4, we get quotient 0.5. So x is basically 0.75. Now to find y, let's substitute this value of x, which is 0.75, in equation 1. So our equation 1 is x plus y equals 0.5. So first I'm going to write equation 1, which is x plus y equals 0.5. And now I'm going to replace this x by the value 0.75. So this equation becomes 0.75, which is the value of x, plus y equals 0.5. And now to find y, I'm going to take this positive 0.75 from left to the right side. So this equation becomes y equals 0.5, as it is negative 0.75. Or you can also subtract 0.75 on both sides of this equation. So we can eliminate positive 0.75 from the left hand side. So now subtract 0.5 from 0.75, the difference is negative 0.25. So what was the value of x? So I have 0.75, and the value of y is negative 0.25. So therefore the solution of the simultaneous equations is x equals 0.75 and y equals minus 0.25. Now second part from this question, actually we are solving intermediate levels questions from this exercise 2E. So second part from this question 5 is 2x plus 0.4y equals 8, and the second equation is 5x negative 1.2y equals 9. So step 1 is to name these two equations as equation 1 and equation 2. And let's see, in equation 1 the coefficient of x is 2, and in equation 2 the coefficient of x is 5. Same as in equation 1 the coefficient of y is 0.4, while in equation 2 the coefficient of y is negative 1.2. So basically simultaneous equation, the elimination method is used when the absolute values of the coefficients of one variable in both the equations are the same. But here the situation is totally different. We have two different absolute values of the coefficients of x and y in these two equations. So I'm going to multiply equation 1 by 5 and equation 2 by 2. Let's multiply equation 1 by 5. So 5 times 2, 10x plus 0.4 multiplied by 5 equals 2 with the variable y, and 8 times 5 equals 40. And same as I'm going to multiply this equation 2 by 2. So 5 times 2, 10x, and 1.2 multiplied by 2, we get 2.4y, and 9 times 2, 18. So now we have the same absolute values of the coefficients of variable x in equation 3 and in equation 4. Since both coefficients are positive, so we can eliminate this variable x from equation 3 and 4 by subtracting equation 3 and 4. So I'm going to subtract equation 3 from 4. Since we are subtracting 3 from 4, so first I'm going to write the left hand side of equation 4, which is 10x minus 2.4y, and negative signs because we are subtracting left hand side of equation 3, which is 10x plus 2y, equals right hand side of equation 4, 18, minus right hand side of equation 3, 40. Let's simplify 10x minus 2.4y as it is. We have negative sign here, so minus multiplied by plus is negative 10x, and negative multiplied by positive, negative 2y equals positive 18, negative 40 is negative 22. And now positive 10x and negative 10x, they are like terms, but with different signs, positive and negative, so these two terms become 0. And negative 2.4y and negative 2y, their sum is negative 4.4y equals negative 22. So to find y, let's divide both sides of this negative equation by negative 4.4, or simply you can take this negative 4.4 from left to the right side, so this equation becomes y equals negative 22 upon negative 4.4. So first let's simplify these negative signs. So minus multiplied by minus, it's plus, and let's write the fractional form of 4.4, which is 44 upon 10. And we can also write this fraction as 22 multiplied by the reciprocal of 44 upon 10, which is 10 upon 44. And now 22 and 44, they are the multiples of 2, they are the multiples of 11, or you can also divide 44 by 22. So 22 ones are 22 and 22 twos are 44. And now the fraction is 1 multiplied by 10 upon 2, so 2 times 1 2 and 2 times 5 10, and now 5 multiplied by 1 equals 5. So the value of y is 5. To find x, let's substitute y equals 5 in equation 1. So first I'm going to write equation 1, which is 2x plus 0.4y equals 8. And now I'm going to substitute y equals 5 in this equations. So this equation becomes 2x plus 0.4 into 5 equals 8. Next step is to take the product of 0.4 and 5. So the product is 2. So we get 2x plus 2 equals 8. And further simplification is to take this positive 2 from left to the right side, or you can also subtract 2 from both sides of this equation. So 2x equals 8 minus 2. 8 minus 2 is 6, and if we take this 2 from left to the right side, so this total equation becomes x equals 6 upon 2. Since 6 is the multiple of 2, so 2 times 3 is 6. Therefore, the solution of the simultaneous equations is x is equal to 3 and y equals 5. Third part from this question, 10x minus 3y equals 24.5, 3x minus 5y equals 13.5. So again, we have two different values for the coefficients of variable x and variable y in both the equations. So step 1 is to name these two equations as equation 1 and equation 2. And now I'm going to multiply equation 1 by 3 and equation 2 by 10. Because we have two different values of the coefficients of x and y in these two equations. So if we multiply equation 1 by 3, and 10 times 3 30, 3 times 3 9, and 24.5 multiplied by 3 is 73.5. And I'm going to name this equation as equation 3. And next I will multiply equation 2 by 10. So 3 times 10 is 30, 5 times 10 50, and 13.5 multiplied by 10 it's 135. So this is our equation 4. And now if you check, we have two same values for the coefficients of x in equation 3 and in equation 4. Since both coefficients are positive, so we can eliminate variable x from these two equations by subtracting equation 4 from 3, or you can also subtract equation 3 from 4. So first I will write left hand side of equation 3, which is 30x minus 9y, minus left hand side of equation 4, which is 30x minus 50y, equals right hand side of equation 3, which is 73.5, minus right hand side of equation 4, which is 135. And now simplification, 30x minus 9y as it is, negative multiplied by positive 30x, it's negative 30x, and negative multiplied by negative positive 50y, and 73.5 minus 135, the difference is negative 61.5. Now positive 30x and negative 30x, they are like terms with different signs, with opposite signs, so their sum or difference is 0. So we have negative 9y, positive 50y, their difference is 41y, equals minus 61.5. To find y, I'll take this 41 from left to the right side, so this equation becomes negative 61.5 upon 41. So if you divide 61.5 by 41, we get 1.5, negative 1.5. So I'm going to substitute this value of y in equation 1 to find the value of x. So first I will write equation 1, which is 10x minus 3y equals 24.5. And now I'm going to substitute y equals minus 1.5 in this equation. So this equation becomes 10x minus 3 into minus 1.5 equals 24.5. Next step is to take the product of negative 3 and negative 1.5. The product is positive 4.5. Let's take this positive 4.5 from left to the right side in the next step. So this equation becomes 10x, 24.5, positive 4.5 becomes negative 4.5. Subtract 4.5 from 24.5, so we get 20. And now to find x, let's take this 10 from left to the right side. So this equation becomes 20 upon 10, and 20 is divisible by 10, so 10 times 2 equals 20. So therefore the solution of the simultaneous equations is x is equal to 2 and y equals negative 1.5. Fourth part from this question, two linear equations are given. 6x plus 5y equals 10.5, 5x negative 3y equals negative 2. Step 1 is to name these two equations as equation 1 and equation 2. And now I'm going to multiply equation 1 by 5 and equation 2 by 6. So 6 times 5 30, 5 times 5 25, and 10.5 times 5 52.5. And let's multiply equation 2 by 6. 5 times 6 30, 3 times 6 18, and 2 times 6 12. So and now we have the same values of the coefficients of variable x in equation 3 and equation 4. So now to eliminate x, let's subtract equation 3 from 4 or equation 4 from 3. So first I will write the left hand side of equation 4, which is 3x minus 18y, negative left hand side of equation 3, which is 10x plus 25y, equals right hand side of equation 4 minus 12, subtract right hand side of equation 3, 52.5. And now simplification, 30x negative 18y, negative multiplied by positive 30x, it's negative 30x, and minus multiplied by plus minus 25y equals negative 12, negative 52.5 equals negative 64.5. Now positive 30x, negative 30x will cancel out. So negative 18y, negative 25y equals negative 43y, and right side negative 64.5. Let's take this negative 43 from left to the right side. So this equation becomes y equals negative 64.5 upon negative 43. Again, minus multiplied by minus plus, and if we divide 64.5 by 43, we get 1.5. So y is equal to 1.5. Now to find x, I'm going to substitute y equals 1.5 in equation 1. You can also substitute y equals 1.5 in equation 2. It's your choice. So now equation 2 is 5x minus 3y equals negative 2, and y is 1.5, so this equation becomes 5x minus 3 into 1.5 equals negative 2. And now 3 multiplied by negative 3 multiplied by 1.5 is negative 4.5, and in the next step I'm going to take this negative 4.5 from left to the right side. So this equation becomes 5x equals negative 2 plus 4.5. Now negative 2 plus 4.5 is positive 2.5 because we will subtract 2 from 4.5. And now to find x, let's take this 5 from left to the right side. So this equation becomes x equals 2.5 upon 5. And if you divide 2.5 by 5, you will get x is equal to 0.5. So therefore, the solution of the simultaneous equations is x is equal to 0.5 and y equals 1.5. Now, question number 6 from intermediate level questions. By using elimination method, solve each of the following pairs of simultaneous equations. Okay, two equations are given, 4x minus y minus 7 equals 0. And second equation is 4x plus 3y negative 11 equals 0. First, I'm going to name these two equations as equation 1 and equation 2. Secondly, I will take this negative 7 and negative 11 from left to the right side. So these two equations are 4x minus y minus 7 becomes positive 7 on the right side, and 4x plus 3y negative 11 becomes positive 11 on the right side. So now equation 1 and 2, since we have this absolute values for the coefficients of x in both the equations same, which is 4, so we can eliminate this terms in x by subtracting equation 1 from equation 2. So first I will write the left hand side of equation 2, which is 4x plus 3y, and minus left hand side of equation 1, which is 4x minus y, equals right side of equation 2, which is 11, minus right side of equation 1, which is 7. Simplification, 4x plus 3y as it is, and now I'm going to multiply this negative sign by positive 4x and then by negative y. So this becomes negative 4x minus multiplied by minus plus y, and let's subtract 7 from 11, we get 4, and now positive 4x and negative 4x, they will cancel out. So 3y plus y equals 4y is equal to the right side 4. And to find y, I'm going to take this 4 from left to the right side. So this equation becomes 4 upon 4. And 4 divided by 4 equals 1. So the value of y is 1. Now it's time to find the value of x. So substitute y equals 1 in equation 1. First, I'm going to write equation 1, which is 4x minus y equals 7. And then I'm going to substitute y equals 1 in this equation. So this equation becomes 4x minus 1 equals 7. And then 4x equals 7 minus 1 becomes positive 1 if we take this negative 1 from left to the right side. So 7 plus 1 equals 8. And now 4x is equal to 8. To find x, I'm going to take this 4 from left to the right side. So this equation becomes x is equal to 8 upon 4. And now x is equal to 2, which is the value of x. So therefore, the solution of the simultaneous equations is x is equal to 2 and y is equal to 1. Second part from this question, 7x plus 2y negative 33 and 3y minus 7x equal minus 17 equals 0. You see, we have the same coefficients of variable x in equation 1 and in equation 2. So let me arrange this equation 2, and I will also take this negative 33 and negative 17 from left to the right side. So step 1 is 7x plus 2y, negative 33 becomes positive 33. I'm going to name this equation as equation 1, and I'm going to arrange this equation 2, or let me write it as it is. 3y minus 7x equals negative 17 becomes positive 17 on the right side. Let's add these two equations to eliminate variable x, because in both the equations x is having same coefficient 7 and minus 7. So if we add these two equations, first I will write left hand side of equation 1, which is 7x plus 2y, and then left hand side of equation 2, which is 3y minus 7x, equals right side of these two equations 33 plus 17. Let's simplify 7x plus 2y as it is, plus 3y and plus multiplied by minus 7x equals their sum 33 plus 17 is 50. And now positive 7x, negative 7x, they will cancel out, and positive 2y plus 3y equals 5y is equal to 50. To find y, let's take this 5 from left to the right side. So this equation becomes y equals 50 upon 5. And if we divide 50 by 5, we get y equals 10. So now to find x, let's substitute y equals 10 in equation 1. And equation 1 is 7x plus 2y equals 33. So what is y? It's 10. So this equation becomes 7x plus 2 multiplied by 10 equals 33. The product of 2 and 10 is 20. And then let's take this 20 from left to the right side. So this equation becomes 7x is equal to 33 minus 20. Subtract 20 from 33, we get 13, and finally x is equal to 13 upon 7. You can also express this improper fraction as a mixed number, which is 1 whole 6 upon 7. So therefore, the solution of the simultaneous equations is x is equal to 1 whole 6 upon 10 and y equals 10. Third part from this question is 5x minus 3y minus 2 equals 0 and x plus 5y minus 6 equals 0. First, I'm going to name these two equations as equation 1 and equation 2, and I will also take this negative 2 from left to the right side and negative 6 from left to the right side. So these two equations are equation 1 and equation 2. We have the coefficient of x in equation 2, 1, and the coefficient of x in equation 1 is 5. So it means that we have two different coefficients for x in equation 1 and equation 2. So if I multiply equation 2 by 5, then equation 2 becomes 5x plus 5 5s are 25, 6 5s are 30. And now let's compare equation 1 and equation 3. We have the same values of the coefficients of variable x in these two equations. So let's subtract equation 1 from 3 to eliminate terms in variable x. So now subtracting equation 1 from 3, I will write first left hand side of equation 3, which is 5x plus 25y, because we are subtracting 1 from 3. If it is subtract 3 from 1, then I will write left hand side of equation 3 and then left hand side of equation 1. Anyhow, 5x plus 25, which is the left side of equation 3, minus 5x minus 3y is the left side of equation 1. Same as right side of equation 3, 30 minus right side of equation 1 is 2. Now let's simplify 5x plus 25y as it is. Here I'll multiply negative sign first by positive 5x and then by negative 3y. So minus multiplied by plus, minus, and minus multiplied by minus is plus 3y equals 30 minus 2, 28. So positive 5x, negative 5x is 0. plus 25y plus 3y, this sum is 28y equals 28, and y is equal to 28 upon 28, so y is 1. And now let's find x by substituting y equals 1 in equation 1. So equation 1 is 5x minus 3y equals 2. So what is y? It's 1. So this equation becomes 5x minus 3 into 1 equals 2. 3 ones are 3, it's 5x minus 3 equals 2. And I'm going to take this negative 3 from left to the right side, so this equation becomes 2 plus 3. And then x is equal to, okay, their sum is 5. And then x is equal to 5 upon 5, which is 1. So therefore, the solution of the simultaneous equations is x is equal to 1 and y is equal to 1. Next part, fourth part from this question is 5x minus 3y minus 13 equals 0. 7x minus 6y minus 20 equals 0. So step 1 is to name these two equations as equation 1 and equation 2. Since we have two different values for the coefficients of x in both the equations, so I'm going to multiply equation 1 by 2. So if we multiply equation 1 by 2, we can change this negative 3 into negative 6. So we will be having the same coefficients of variable y in these two equations. So let's multiply equation 1 by 2. Then 5 times 2, 10x, 3 times 2, 6y, and 13 times 2, 26. And if we compare equation 2 and 3, we are having the same values of coefficient y in both the equations, negative 6 and negative 6. So I'm going to subtract equation 2 from equation 3. So first I'll write left hand side of equation 3, which is 10x minus 6y and then 7x minus 6y equals 26 minus 20. And now 10x minus 6y minus 7x minus multiplied by minus plus 6y, and if we subtract 20 from 26 we get 6. So now negative 6y, positive 6y, they become 0, and 10x minus 7x is 3x equals 6. And to find x, let's take this 3 from left to the right side. So this equation becomes x equals 6 upon 3, and 3 times 2x, so x is equal to 2. To find y, let's substitute x is equal to 1 in equation 1. So our first equation is 5x minus 3y equals 13, and I'm going to substitute x equals 2 in this equation. So this equation becomes 5 into 2 minus 3y equals 13. And now 5 times 2, 10, minus 3y equals 13. And let's take this positive 10 from left to the right side, so this equation becomes negative 3y equals 13 minus 10. And then 13 minus 10, their difference is 3. To find y, let's take this negative 3 from left to the right side. This equation becomes 3 upon negative 3. So their quotient is negative 1. So therefore, the solution of the simultaneous equations is x is equal to 2 and y is equal to 1. Another part from this question number 5, intermediate level questions from this exercise. Two linear equations are given. First linear equation is 7x plus 3y negative 8 equals 0, and the second equation is 3x minus 4y minus 14 equals 0. So first I'll take this negative 8 and negative 14 from left to the right side, and then I will name these two equations as equation 1 and equation 2. And if you check the coefficients of these two variables x and y, so we have different values for the coefficients of x and y in these two equations. So I'm going to multiply equation 1 by 3 and equation 2 by 7. So 7 times 3, 21x, 3 times 3, 9, and 8 times 3, 24. Same as equation 2 by 7, 3 times 7, 21, 4 times 7, 28, and 14 times 7, 98. And now we are having the same coefficients of x in both the equations. So let's subtract equation 3 from 4 to eliminate terms in variable x, or to eliminate x from these two equations. So first I will write left hand side of equation 4, which is 21x negative 28y, and then left hand side of equation 3, which is 21x positive 9y. Same as first I will write the right hand side of equation 4 and then right side of equation 3. And now simplification. I'll multiply this negative sign by positive 21x and by positive 9. So this equation becomes 21x minus 28y minus 21x minus multiplied by plus minus 9y equals 98 minus 24. Their difference is 74. Positive 21x, negative 21x, they will cancel out. So their difference is 0. Let me cancel out these two terms. Yes. Yeah. And now negative 28y and negative 9y is equal to negative 37y equals 74. And to find y, let's take this negative 37 from left to the right side. So this equation becomes 74 upon negative 37. Since 74 is the multiple of 37, so 37 times 2, 74. So the value of y is negative 2. To find x, let's substitute y equals negative 2 in equation 1. So this equation, our first equation is 7x plus 3y equals 8. This equation becomes 7x plus 3 into minus 2, because y is negative 2, equals 8. And now 3 times negative 2 is negative 6. And let's take this negative 6 from left to the right side. So this equation becomes 7x equals 8 plus 4. And then their sum is 14. To find x, let's take this 7 from left to the right side. So this equation becomes 14 upon 7. So 7 times 2, 14. So x is equal to 2. Therefore, the solution of the simultaneous equations is x is equal to 2 and y is equal to minus 2. Next part from this question, F part, is 3x plus 5y plus 8 equals 0. 4x plus 13y negative 2 equals 0. I'm going to take this positive 8 and negative 2 from left to the right side, and then I'm going to name these two equations as equation 1 and equation 2. Now let's multiply equation 1 by 4 and equation 2 by 3, because we are having two different coefficients of this variable x in both the equations. So if I multiply 3 by 4 and 4 by 3, so we can get the same coefficients of variable x in these two equations. So let's do it. 3 times 4, 12x, 5 times 4, 20, and 8 times 4, 30, and then 4 times 3, 12, 13 times 3, 39, and 2 times 3, 6. Let's name these two equations as 3 and 4. Since we are having positive 12x in both the equations, to eliminate x from these two equations, I'm going to subtract equation 3 from equation 4. Or you can also subtract equation 4 from equation 3. Anyhow, our left hand side of equation 4, 12x plus 39y, minus left hand side of equation 3, 12x plus 20y, equals right side of equation 4, 6, minus right side of equation 3, minus 32. So simplification, I'll write 12x plus 39y as it is, and I'm going to multiply this negative sign by positive 12x and positive 20y. So negative 12x, negative 20y equals minus multiplied by minus, it's plus, and 6 plus 32 equals 38. Here on the left side, positive 12x will cancel out negative 12x, and 39y minus 20y equals 19y. And then y equals 38 upon 19, and 19 times 2, 38. So substitute y equals 2 in equation 1 to find the value of x. So equation 1, 3x plus 5y equals negative 8, and 3x plus 5 into 2, which is the value of y, equals negative 8, and then 3x plus 10, because 5 2s are 10, equals negative 8. Take this positive 10 from left to the right side. The equation becomes 3x equals negative 8, negative 10. Their sum is negative 18, and then x is equal to negative 18 upon 3, so 3 times 6, 18. So therefore the solution of the simultaneous equations is x is equal to negative 6 and y is equal to positive 2.